Students, and welcome again to my channel. My name is Mr. Meshak Ngigi and welcome to eMath with Meshak Ngigi. So today again, we're going to be checking on a Fourier series, some few questions, Fourier series. And we are still checking on analytical descriptions, so of different functions. That is not straight enough. So we're going to be checking analytical descriptions. Remember, if you have not checked in the first video that we did, kindly check it out. We move along now. So we checked on two examples. We'll check other two examples for us to get the description. So we have this function ft. So we have a function ft, and the function will be given by this. So let me just draw it. Sorry. So let's sketch the function. And the function runs from this point to this point. Then from this point, then from this point. Okay, something of such. So you have negative pi, 0, and you have pi, then you have pi. So we have t. So you have t here, and you have f of t. So you're supposed to get the analytical description. So remember, that is what we are doing in this particular lesson. If you have not subscribed, kindly subscribe, share, and also comment. So we're doing analytical description. So, and remember, again, this is simple. If you are able to understand what happens with lines, then really getting this should not be an issue. Together. Now, so we check this. So we get our points in this part. So first of all, we can just get a general representation. So ft. So we can split again these into two. We have negative pi to 0, 0 to pi. I hope you remember that. If you have not checked the previous video, kindly check it out so that you can understand what really happens. So we have negative pi t. Those are the limits, okay, of the two lines. Remember, these are two lines. We have this one and we have this one. And both of them, you can just check here. They all will have positive gradients because they are all going upwards. Okay. Yes, they are both going upwards. So the gradients there will be positive, and I'm sure you can really guess where what the gradients are. Why? Because we have the change in with respect to x and with respect to y are the same, from 0 to pi, 0 to pi, 0 to pi, negative pi to 0. So can have that. But for the sake of calculations, let's just work it out. So we have our first point, the first point here. So let me mark them. So you have that point, you have that point, you have that point, and you have that point together. So for the points, okay, let me use the red marker. For the points we shall have, so we can say P1 is the first point, which is negative pi, then 0. Then you have P2, which is 0 pi, okay, 0 pi. So we check the gradient, which is change in y over change in x. So change in y, pi minus 0, then 0 minus pi. So pi minus 0 gives you pi, 0 minus pi, so gives you pi. So you get what? You get 1, then you add t. So remember, again, we are writing these ones are straight lines, okay? And since our variable is t, so this is the equation of a straight line. Y is equals to mx plus c. But since we're using t as a variable, so we have mt plus c. So our m is what we have gotten here, which is 1. Then we add out a t. So this part here is given by this. And this part here is what we shall have as our first representation there. Let me write it correctly. Something visible. So we have t. Okay. Then we just check, where does the line cut the y-axis? That will be your c. So it cuts the y-axis at what? At pi. So plus pi. It is positive 1t, which is just t. Okay. Remember, this one is t by the end of the day. Right. So it will be pi plus t. So the positive t is whatever you have here. So it has to be positive. Are we together? Yes. So then where it cuts the y-axis, it is at pi. Okay. Let's come to the second. So you can say this one is P3. It is 0, 0. Okay. This point here. Are we together? Then this point is pi, pi. Pi, pi. This pi go upward, pi. So pi, pi. So again, subtract pi minus 0, pi minus 0. So our gradient will be given by pi minus 0 over pi minus 0, which is pi over pi, which is 1. Then you add what? T. So t. So your mt is 1t. So it is t. It is t there. Now, then positive. Remember the positive there is necessary, important. So it has to be positive here. Then where does the line cut the y-axis? It doesn't cut the y-axis. Or you can just say it only cuts the y-axis at point 0, 0, 0. So if I just put 0 here, there's no difference. Right together. Yes. So basically, it's just t. So you can just have this, and we have that. So then that is your function. From this point to this point, so it is pi plus t. Then you have 0, pi, and you have that. And you can always prove them. So if you put negative pi here, remember, we said you can always prove. Prove your outcomes. So we have t, we have t, we have t, we have t, 0. Sorry, that last one should be. So we have, let me just put that. So we have the first limit is negative pi, we have 0, we have 0, and we have pi. That is your t. Then your ft, your ft, your ft, and your ft. Okay. So when this one is negative pi, we put it in the function. So negative pi, so 0 plus negative pi gives you 0. Then when this one is 0, this one is pi. So for the first two functions. So it is 0, negative pi 0, this point, then 0 pi, 0 pi. Then the other one, when you put 0 here, you just have 0. And remember this one is pi, not 0. So have pi here, not 0. So we are saying, then when you put pi here, so remember pi, we have pi, so it's just pi. So you have 0, 0, pi, pi, 0, 0, pi, pi. So therefore, this is your function. As easy as that. Let's check the second one. Our function is given by this. So and you can see if I was to flip this function along the y-axis, this function will not be an even function because this line here will lie here. And together, yes, this particular line here will lie directly here. And you can see where the other line is. Okay, so that already says this function is not even nor odd. Because for an odd function, whatever you have on this side should be on this other side, or on this side should be on this other side. So it is neither an even function or an odd function. All together? Yes. And again, remember this one is November. November deck 2024 series. November, December 2024. So you have that. Now, again, then you can see the function. The function runs from this point to this point. So what is the total period for the function to repeat itself? It is 2 pi. okay, because it is from 0 up to 2 pi, then from 2 pi to 4 pi, 4 pi to 6 pi, and so on and so forth. That will be the completeness of the function. So you can choose to split it into two also. From this point to this point, we have the line, then we have this line from here to here. Now, so our function qt be given by, so we can split it from 0. So our function is t, okay, then up to pi, then from pi t up to 2 what? Up to 2 pi, okay. Yes, because it starts repeats itself after 2 pi. So we have that. Then now let's check. So we have different points. So we have this point, we have this point, we have this point, and we have this point, okay. But already we can already find this part here, this line here. If I was to stretch this line, I'll have a straight line whereby my values of y do not change. Right together. So what will be the line? What will be this line here? It will be the line y equals to -1. The y value does not change, only the x value changes. And what is our y here? Our y is our qt. Right together. So from pi up to 2 pi, from pi to 2 pi, this one is just -1. We don't even need to calculate it. Right together. Yes, this one is -1 because this one from here to here is -1, from pi to 2 pi. So we already have that. Now let's come to the first part and see. So we can have our P1. So what is our point? 0, 0. Then P2. What is our point? Pi 2. Remember, it is this point, then up here. So x, y. So it is pi, then 2. Okay. So we find our gradient here will be, and subtract the beginning. So 2 minus 0. And subtract the beginning. So pi minus 0, right together. So it will be 2 over pi. And remember, again, our function should be written in the form of mx plus c, but we have our variable being t. So it's just the same thing, eh? Just change, instead of x, we have t. So this one is our m, is the gradient, this part here, this part here. So what do we add now for us to get the complete part here? We add out a t. So therefore we say this part here is given by 2 pi over t. No, 2 over pi and t. It is 2 over pi then t. Then we just check now the last thing. Where does the line cut? This line, does it cut the x-axis? The y-axis? Yes, but at where? 0, 0. So if I add 0, 0 here, there's no effect. And this is your function by the end of the day. This 2 pi, 2 over pi t, that is from 0 to pi, then -1 from pi to 2 pi. Now, not something interesting here. When you're calculating the Fourier series, the Fourier series from pi to 2 pi will be 0. Why? Because we are dealing with a what? We're dealing with a constant. Together. So you'll find that when you're doing the Fourier series, you'll only deal with this part majorly. But we shall see that. We shall do another video where now we calculate the Fourier series. But now we are just doing the what? The analytical description for this function. So the function now that gave you this outcome is 2 over pi t from 0 to pi, -1, pi up to 2 pi. We can check the last one. We have some few minutes. Let's now check the last function. And again, this is from neck paper. So again, can't remember the series, but it's a neck paper. So let's have it. So we have so we have that. That was the function. Again, this one was ft. Then So therefore this one is t. Okay, we have pi over 2, we have pi, we have 0. Okay, so we have this. Now, so we have that. Now this function, the way you can see it, you cannot really tell if it is an even function or a not function, because it can be a half range function by the end of the day. Because this function can be, you can make this function to be odd, or you can make this function to be even. If I want to make this function to be even, I just create a new line on this other side. So what do I have? For it to be even, I just have that and that. You see that? That will make my function to be even. If I want to make it to be odd, I just add this. Okay, because remember, for odd functions, they are symmetrical along the origin. For odd function, yes. Then for even functions, they are symmetrical along the y-axis. So whatever you have here should be here. For odd, whatever you have here should be on the opposite side, right, together. But now let's just focus on getting the what. We shall see. I'll find out where this in which paper this one belongs to, but our core interest here is just to find the analytical description. So now let's do that. Now again, we split this function into two. We have from 0 to pi over 2, and we have up to pi. Now together, yes. So from 0 to pi over 2 up to pi. So that is the total period for that function. So therefore, your ft given by, so we start with our limit, t up to pi over 2. Then from pi over 2 up to pi. Okay, and you can see these are two lines. One is going upwards, one is going downwards. So one will have a positive gradient, the other one will have a negative gradient. All right, yes. Now, so we check our P1. Our point P1 is 0, 0. Okay, so we have this point, we have this point, and we have this point. Okay, then we have P2 will be what? Pi over 2. Function here was pi, sorry. So you have pi there. So pi over 2 pi. So we check the gradient. So it will be this minus that. So only pi minus 0. Then you have pi over 2 minus 0. Okay. Yes. So pi, you have pi, then pi over 2. This is the same as saying pi multiplied by 2 over pi. Excuse me. Yeah, this one is a fraction, this one is so you just reciprocate the fraction in the denominator. So the pi and the pi cancels and you get 2. Then you add what? T. Why? Because y equals to mt plus c. We are dealing with this part here. So for the first part, we have this. Where does it cut the y-axis? Yes, at what? 0, 0. So it will just be 2t. If it cut the y-axis at any other point, we'll have written the point, but at 0, 0, so just add, it's just the same as saying add 0 there. And you can see that really doesn't make any difference in the function. Okay, yes. The 0, 0 is this c. Are you together? So now let's go to the other part. So the first part is 2t, that is your function. Let's come to the second part. So we have p3. What is our p3? Again, it is pi over 2 pi, pi over 2 pi, okay? And we have p4, it is pi 0. Again, and subtract the beginning, so 0 minus pi over pi minus pi over 2. And then one is pi minus pi over 2. So again, this one is negative pi, this one is negative pi over 2. This is just the same as saying 1 minus a half. It's just negative a half, okay? So we just have that again. No, this one is not negative, it will be positive, sorry for that. So we have one is positive. So we have negative pi over 2. So this one again is negative pi times 2 over pi. And that goes, you get negative 2. Then you add what? T. Right together. Yes, you add the t. So this one will be negative 2, negative 2t. By the way, it really doesn't matter which one you start with. You can start with the mx, then c follows. Or just a rearrangement, okay? Yeah. Now, let's, so we have that. Then let's check the second function. Where does it cut the y-axis? Does it cut the y-axis? No, it does not cut the y-axis. But let's check our limits and see what that one gives us, if that satisfies this particular function. So for the first part, I think it is direct forward. So when you put 0, the whole of this becomes 0, 0. So you have 0, 0. So the first one checks. When you put pi over 2, you get pi. That one checks. Now let's come to the second. When you put pi over 2 here, let me change my pen. Let's see. When you put, so where are we? So you have negative 2, okay? When we put pi over 2, remember we're just changing the value of what? The value of, the value of what? The value of t. So if this and this cancels, remember we're putting now pi over 2, but here we have a negative. So what will you have as your answer? Negative pi. Okay, but is that true? No, it is not true, because why? When you put pi over 2, your answer should be pi. You see that? So when you put that, you should have that. So what makes the difference here? So what we'll just need to just do here, it's add a pi, but since our what? Our x values between pi over 2 and pi differ, is twice, okay, is twice the change in y. We can have our pi, but now we put it in terms of 2 pi instead of just pi. Right together. So because we have a difference in terms of x value, the change in the x values is twice the change in the y value. Right together. So I'll put a pi here so that I can see if this function indeed can, because this is not true. Right together, because I'm supposed to get a value of pi. Okay. Yes. So now I put it in terms of twice of pi. So I insert just 2 pi here. So now let's check the difference. So now let's put again 2. So if I where are we? Yes, so if I input negative, if I input pi over 2 here, I'll get negative pi. So 2 pi minus pi, what will I get? Pi. Now that one is being fulfilled. Right together. Then the last one, I take pi. So when I input pi here, I'll have 2 times pi, which is 2 pi. So I'll have 2 pi minus 2 pi is 0. So therefore, the third part checks. So therefore, my function for this particular function will be given by that. Are we together? Yes. So and this function, again, I said, it can either be even or odd. But as it is neither even or odd, neither right now. But if you're told to now calculate the odd part of it, then it can be calculated. If you're told to calculate the even part, then also that can be calculated. So thank you so much for watching across. And I think for functions, for analytic descriptions, so far we'll have those ones. So thank you so much. And now in our next video, we shall now see how to calculate. So especially this function here, we shall calculate this particular function. We shall get the Fourier series for it. Maybe we have another function which you have done. You can also check this one, this particular function, and see the Fourier series. So thank you and see you in the next lesson. Kindly, if you have not subscribed, do what? Subscribe. Also, kindly share to your colleagues to reach as many people as possible. And also, don't forget to do what? Don't forget to comment in the comment section.